Okay, good morning. I think this is 124.
123. GreatMath124.
Okay. So your brother and I are doing a fun project talking about these four-dimensional objects. Do you remember what this one's called?
A 5-cell.
This one's a 5-cell. What's this one?
This one's an 8-cell.
And it also has another name.
A hypercube.
A hypercube. And then the strange thing is these two are the same.
Yep.
What are those called?
They're 16 cells.
16 cells. And so the project your brother and I are working on is, which one of these is most like a sphere? A four-dimensional sphere.
What does a 4-dimensional sphere look like?
Yeah, I know. It's really weird to even kind of think about that. What do you think a four-dimensional sphere looks
I
like?
think it's like a sphere with a sphere inside it somehow.
A sphere
and
with
more spheres.
And more spheres. Okay. Yeah. Kind of. Yeah, we should talk about it. Like how do you go? Sometimes it's easiest to think with squares and cubes and hypercubes, but also circles and spheres and hyperspheres are kind of fun to think about. But which one? Why don't we talk about the three-dimensional objects first? A tetrahedron, a cube, and then the analog of this is an octahedron. Which of those do you think is most like a sphere?
Well, I would say this. It has a lot of curved parts, but the octahedron, yeah, it has the most vertexes of all of those. And that kind of makes it more rounded.
Interesting. Okay. What about, which one do you think is the least like a sphere?
This one doesn't have it's a tie between this one and this one. They don't have a lot of vertexes on the outside.
Yeah. Yeah, interesting. Okay, so in 3 dimensions, a tetrahedron probably is least like a sphere. And this is, in 3 dimensions, this looks like a tetrahedron, even though this is the 16 cell. Now, in 4 dimensions, maybe to clear up the picture, move that away. In 4 dimensions, which do you think of these ones as least like a 4-dimensional sphere?
Well, again, it's these two. They don't have a lot of vertexes on the outside.
Yeah, interesting. And what do you think is the most like a sphere?
I think it was that 16 cell, again, because it had the most vertexes.
Yeah, it's interesting then, but this is the 16 cell. Isn't that strange?
Maybe like this variation of the 16 cell.
Yeah. So, bring that back. So these are the same, different projections of the same shape. So this one, in this projection, it looks maybe like it's a lot like a sphere and very different than this.
Yeah.
In this projection, it looks very similar to this. But it's the same shape in 4 dimensions, and that's what makes things a little confusing in 4 dimensions. What do you think is the best way to think about the 16 cell? This way or this way?
This way.
How come?
Well, actually, so you can see the tetrahedrons a lot better.
Yeah, you can see the tetrahedrons a lot better, but it also makes you think that it's a very similar looking shape to that. Huh. 4 dimensions pretty wacky, don't you think?
Yeah.
What else? What are some of your other thoughts about these shapes in 4-dimensional spheres?
I think it's kind of like the 4-dimensional sphere would kind of be like circle packing, like the sphere packing. So if you had like a spherical box and you put tiny spheres inside it.
Oh yeah? You think that's how you would make a 4-dimensional sphere? Interesting. Okay, well, maybe this weekend we'll do a project and try to understand what a 4-dimensional sphere looks like.
Okay.
All right, good work today.